In this video, we will go over the steps to communicate with the TITAN-SVX 5.0 controller by using Wi-Fi communication. Here we have a TITAN-SVX 5.0 configured and ready to run using a brushless 3-phase motor. We also have a simple standalone motion program ready to run for our demonstration later. Before starting, confirm that the Titan software is 6.28 or above, which supports wireless Wi-Fi communication. Confirm that the wireless Wi-Fi router is running, and you have the SSID and the password of the wireless router. Note that we can use various platforms for Wi-Fi communication with the Titan, such as Windows, Mac, or Linux, as well as Android and iOS. In this demonstration, we will use a Windows PC laptop, so confirm that the PC is connected to the router by Wi-Fi or by wire. In this example, the laptop is connected to the router by Wi-Fi. Let's configure the Titan Wi-Fi settings using USB. Confirm the communication. Go to the configuration screen and enter the same SSID and the password of the wireless router. Download the new settings and store them to flash. Perform a power cycle for the new SSID and the password to take effect. You can visually check the Wi-Fi connection by checking the wireless status LED on the TITAN-SVX 5.0. If the Wi-Fi connection is successful, you will see the LED blinking once every second, ready and waiting for a connection from a client. If the connection with the Wi-Fi router is not successful, the LED will blink rapidly 5 times a second. If this happens, double-check the SSID and the password and try again. With the LED blinking once every second, the Titan wireless server is running and ready for connection from a client. For the client to connect to the wireless server on the Titan, the client needs to know the IP address of the server. To find out the IP address of the server, go to the communication screen and under the USB tab page, click the Wireless Setup button. Here you will see the SSID, the password, and the IP address of the server running on the TITAN-SVX 5.0. If the IP address is all 0, that means the connection with the Wi-Fi router is not successful, so redo the wireless setup in the configuration page and confirm the connection before proceeding. Copy the IP address of the server, go to the Wireless Communication tab page, and paste the IP address. Perform the wireless communication check to confirm that the communication with the Titan wireless server is working. If the client can connect and communicate with the server, you will see various version numbers of the Titan controller and wireless server. Close the communication setup and go to the test drive screen. Here you will see the same IP address of the server that was used in the wireless Wi-Fi communication check screen. Press Connect. You will see the client communicating with the Titan server and the motion status values updating. Here you see the digital input and output status as well as the LED and RGB light status. You can toggle the digital output, the LED, and the RGB by clicking on the respective boxes. In the motion control section, you will be able to servo on, servo off, and clear errors. You will also be able to perform various motions such as target position, jog, and home moves. You can run and stop any standalone motion programs. Here you will be able to read and write variables. And here you will be able to send manual commands. Click the down arrow button and you will see the messages that are coming back from the server. Let's servo on the motor. You see the status showing that the motor is enabled and in position. Let's set the speed to 100 and acceleration-deceleration values to 2000 and try some jogging motion. You can also enter positions and perform target moves. We have preloaded a standalone program too on the Titan, so let's try running and stopping the standalone program too. With the PC program running, we will now try the communication on an Android OS mobile app. Before starting the app, confirm that the mobile device is connected to the same Wi-Fi network. Open the app and you will see the test drive screen that is mostly the same as the PC version. Enter the IP address of the Titan wireless server. This is the same IP address that you used on the PC. Connect and confirm communication. All the functions that are available on the PC version are also available on the mobile app. Let's try running and stopping a standalone program from the Android device. Perform jogging and target moves. Keep the connection and the programs running on the PC and the Android device, and now we will communicate from an iOS device. Go through the same steps and confirm the communication on an iPhone. You can see the Titan wireless server that is connected and serving 3 clients at the same time, one on Windows PC, one on an Android device, and another on an iOS device. Up to 3 wireless concurrent connections are supported on the Titan wireless server. For the mobile app versions, we have both the Android and iOS versions available, so check out the respective app stores. For the Windows PC version, make sure to use the Titan software version that is 6.28 or above. If you're interested in developing your custom software, we have the application note and example source codes available, so contact our support team for more information. If you're using a Wi-Fi router that is shared with many other devices, the response may become slow. So, for a faster and consistent response, consider using a dedicated router just for Titan Wireless Network. Please note that the wireless Titan control is for demonstration only and not meant for active motion applications, especially if the motion is set in any critical motion environment. If you're doing active wireless motion control, make sure to confirm and use various safety features available on the Titan. You can enable error checking features, such as position error and current error monitoring, as well as soft or hard limits if available. Also, consider enabling the ping communication check feature in the configuration. Ping setting will stop the motion and standalone program automatically when the communication is idle for a set amount of time. For example, this feature will be useful in cases when the motion or program is running and communication breaks and needs to automatically stop the motion for safety reason. Lastly, we want to emphasize and recommend again that you use wireless communication mainly for monitoring the motion status, such as the second sight motion health and analytics data, and not use for active control of the motor. We hope that this demonstration has given you a good idea of using Wi-Fi communication with the TITAN-SVX 5.0 Servo controller. For more information, please contact our support team.